students, we are talking about sulfur and its compound, and today we are going to talk about oxides of sulfur. And from oxides of sulfur, we are going to start with sulfur oxide. And this is a simple setup showing how sulfur oxide gas is obtained in the laboratory. So, in this diagram, there are some of the things that you need to take note of. One, you should take note of, you must have heat, source of heat. Then you should know this method of collection. Then the drying agent, which is concentrated sulfuric 6 acid, is used at this point. So let me look at a sample question that maybe you can be asked in an exam. So they can just draw for you this setup, this from here, starting from here to this side. Then they tell you complete the diagram to show how dry sulfur oxide gas is obtained. So what are you supposed to do? The first thing that you need to take note of, this delivery tube, you should dip it inside this concentrated sulfuric 6 acid. When you leave it hanging up at the upper side of this, let me say now, for example, you leave it hanging upward. That is a mistake. So you should drop this delivery tube inside this volumetric flask. This is where the examiner is trying to see whether this student know what he or she is doing or he does not know. So this sulfur oxide gas is prepared in the laboratory, as you can see, by reacting dilute sulfuric 6 acid. This is dilute sulfuric 6 acid by sodium sulfite. This is how this sulfur oxide is prepared. You react dilute sulfuric 6 acid by sodium sulfite in the presence of heat, and you will produce you are going to produce sulfur oxide. Then why is it that this gas is passed through concentrated sulfuric 6 acid? The gas is passed through concentrated sulfuric 6 acid so as to dry the gas. This concentrated sulfuric 6 acid is used as a drying agent. Concentrated sulfuric 6 acid is used as a drying agent, which means it is used to dry the gas. Then this method of collection is known as downward delivery. So you can just get an examiner asking you, give the method of gas collection shown in the diagram. So this method of gas collection is known as downward delivery. Why is it that this sulfur oxide is collected by downward delivery? Which means this gas is less than air. The gas is less than air. Is it less than? The gas is less? No, it is denser than air. The gas is denser than air. That's why it is collected by downward delivery. So when you are asked to write the equation that is going to take place, here is the equation that is going to take place. We write the equation between sodium sulfite, this sodium sulfite plus dilute sulfuric 6 acid to get sodium sulfate plus water plus sulfur oxide. The rule of chemistry you must keep them in mind. The equation must have the state symbol and the equation must be balanced. Hope as you are in Form 3, you know how to balance the equation. That is not an issue for a Form 3 student because you are a pre-candidate. Then this, you can also react copper plus sulfuric 6 acid, then you obtain the gas, whereby you are going to form copper 2 sulfate plus sulfur oxide plus water. Copper 2 sulfate plus sulfur oxide plus water. Now let's look at some of the physical properties of sulfur oxide. Let's look at some of the physical properties of sulfur oxide. physical properties. Sorry, this mark pen has some complication, so it's not writing right, but hope you can see. Physical properties of sulfur oxide. So first, it is a colorless gas with an irritating smell. That is a common physical property. Colorless gas. It also has irritating smell. It has a shocking smell. Then it is readily soluble in air. Not in air. Readily soluble in water. Readily soluble in water. In water. So if we say the gas is readily soluble in water, what do we mean? We mean that when the gas can also react with water to form sulfurous acid. This gas can react with water to form sulfurous acid. That gives it its property, which is soluble in water. Then it is denser than air. The gas is denser than air. This is the reason why the gas is collected by downward delivery, because the gas is denser than air. This gas is denser than air. So those are a few physical properties about sulfur oxide. If you want more, you can confirm in KLB, or maybe your teacher can give you those properties. Now let's look at some of the chemical properties, and here is where you will get more questions. Chemical properties. Here students need to be very keen, because here is where more questions usually come. First, it turns a blue litmus paper red. Turns a blue litmus paper red and bleaches it. Turns a blue litmus paper red and bleaches it. Turns blue litmus paper red and bleaches it. This sulfur oxide gas, it turns a blue litmus paper and bleaches it. That's chemical property you need to take note of, because you can get in an exam, they just give you a gas jar, let me say like this, then they put here a litmus paper. They tell you the litmus paper turned from blue to red, and the gas, they just give some of the properties of sulfur oxide. Then they ask you give the name of the gas. So you should keep in mind that. Then acts as an oxidizing agent. It acts as an oxidizing agent. This sulfur oxide oxidizes some elements. It oxidizes some elements. I mean, when an element or a gas that oxidizes another element, like this sulfur oxide. Sorry, let me look at an equation that verifies this oxidizing property. So when you take magnesium, this is a sample equation. Magnesium plus sulfur oxide. What are you going to get? Magnesium plus sulfur oxide, you will get magnesium oxide plus sulfur. Magnesium oxide plus sulfur. This solid, gaseous, solid, then sulfur. So oxidizing agent, as you can see from this equation, this sulfur oxide has oxidized magnesium. It has given its oxygen to magnesium, making it to remain as sulfur, which means it has, in this equation, sulfur oxide has acted like what I mean is that this sulfur oxide, it acts as an oxidizing agent. It oxidizes elements. It gives its oxygen to elements such as magnesium. It gives magnesium its oxygen. So it is an oxidizing agent. Then that oxidizing agent can also be shown when mixed with hydrogen sulfide gas. A yellow solid deposit of sulfur is formed. As a yellow solid of sulfur is formed, and that is also just the same as oxidizing agent. When you mix this sulfur oxide with hydrogen sulfide, you form that one. So next, reducing agent. You see this sulfur oxide, it is oxidizing agent, then it's also a reducing agent. It is also a reducing agent. A reducing agent. Reducing agent. This sulfur oxide, it acts as a reducing agent. Then acts as a reducing agent. In a solution, sulfur oxide reduces acidified potassium manganate 7, or KMNO4 potassium manganate 7 reduces potassium manganate 7 to manganese ion. The potassium manganate 7 is purple, while manganese ion, it is colorless. You can see from this equation, when you take potassium manganate 7, which is purple, this is purple, potassium manganate 7, which is purple, then you react it with sulfur oxide, purple, reacting with sulfur oxide, you are going to see a colorless solution. And this colorless solution, it is manganese ion, which means it is manganese ion. So it is a reducing agent. When you reach in form 4, you will be taught on how to calculate the oxidizing. You will be taught on how to calculate the oxidation number. When you are taught on how to calculate the oxidation number, you calculate the oxidation number like in this equation, and you see how this sulfur oxide has acted as a reducing agent. That one you are going to be taught in form 4, the topic electrochemistry. I will take you through that. Okay. Yes, we were talking about sulfur. So let's look at some of the uses of sulfur oxide. Uses of sulfur oxide, we have bleaching agent, as a refrigerant, manufacture of sulfuric acid. So let's move on. Let's look at sulfur 6 oxide. Lab preparation of sulfur 6. This is a simple setup showing how sulfur 6 oxide is prepared in the laboratory. A simple setup showing how sulfur 6 oxide is prepared in the laboratory. So, preparation of sulfur 6 oxide, we are going to react excess oxygen with sulfur oxide. As you can see here, we have sulfur oxide, and here have oxygen. They are entering in. So excess oxygen and sulfur oxide. So they are first overheated, platinized asbestos. This platinized asbestos. Platinized asbestos. They are passed over this flow in the combustion tube, where in the combustion tube we have platinum asbestos, and here is the source of heat. Then then the gas should be dry, because the gas that we are preparing here, this sulfur 6 oxide, should be dry, because the sulfur 6 gas formed may dissolve in the moisture, because here we have freezing mixture. Here we have freezing mixture. This freezing mixture, and this is the sulfur 6 that you are collecting. This is the sulfur 6 that you are collecting, and here they are going towards here is fume chamber. This side where fume chamber. Then we have thick white fumes of sulfur 6 that are formed condenses in the test tube in form of white silk-like needles. Yes, they will condense because of that freezing mixture. Then the gas can also be prepared by heating hydrated iron 2 sulfate. So when you heat hydrated iron 2 sulfate, focus at that point. When you heat hydrated iron 2 sulfate, you can also obtain the gas sulfur 6 oxide. So we have pale green iron 2 sulfate, hydrated iron 2 sulfate. At that point here, you are going to heat them to form iron 2 sulfate plus water. Then the iron 2 sulfate, which is the residue, is then strongly heated to decompose to iron 2 sulfate, sulfur 4 oxide, and sulfur 6 oxide. So this, we are heating hydrated iron 2 sulfate to form iron sulfate plus water. Then this iron sulfate plus water is further heated, as you can see here. Iron 2 sulfate plus water is further heated to form iron 2 oxide plus sulfur 4 oxide plus this sulfur 4 oxide plus sulfur 6 oxide. Iron 2 sulfate is further heated to form iron 2 oxide plus sulfur 4 oxide plus sulfur 6 oxide, and there the gas is collected. So we are moving very fast. Let's look at the test for sulfate and sulfite ion. We are starting with the test of sulfate ion. So when barium chloride is added to sodium sulfate and sodium sulfite solution, a white PPT is formed in each case. A white PPT are formed in barium sulfate and barium sulfite respectively. A white precipitate is formed in barium sulfate and barium sulfite completely. So this here, this is the white precipitate that you are talking about in barium sulfate and barium sulfite completely. That is the white precipitate that is formed, that I am talking about. Let me repeat for those who have not understood. When barium chloride is added to sodium sulfate and sodium sulfite solution, a white precipitate is formed in each case respectively. The first white precipitate is there, barium sulfate. Barium sulfate is a white precipitate. Then barium sulfite, a white precipitate. That is the test for sulfate. So the test for sulfite, that is the test for sulfite. So HCl is added to the mixture containing barium sulfate. The precipitate does not dissolve. The precipitate does not dissolve. The precipitate that does not dissolve that barium sulfate, as we are told, barium sulfate, it is insoluble, so it does not dissolve. That barium sulfate does not dissolve. So that is the test for sulfite. Let's look at some of the tests for sulfate. Test for sulfate. Test for sulfate. Test for sulfate. Test for sulfate. White precipitate is formed when diluted Cl and barium chloride solution are added to a test solution if the solution is sulfate. White precipitate is formed. So when HCl, dilute HCl, this always this part is a practical part. This test, that's a practical part, but let me just take you through. But when Mr. Jacob will be ready, he's going to take you through that practical part. Barium sulfate plus barium ion plus sulfate ion. We are going to have barium sulfate, which is a white precipitate. Barium sulfate. This is a white precipitate. So this is what I'm talking about. When you take dilute HCl and you add to a solution containing barium, you add to a solution containing barium chloride. First, you are using barium, you are using dilute HCl and you are adding to a solution that contain a sulfate. Like in that case, you are using white precipitate is formed when HCl, dilute HCl and barium chloride are added to a test solution if the solution is a sulfate. Then dilute nitric 5 acid and barium nitrate solution can also be used in place of HCl. You can substitute maybe if you don't want to use HCl, you can use dilute nitric 5 acid. Dilute nitric 5 acid. Then lastly, both sulfite carbonate form white precipitate with barium. Sulfite carbonate form white precipitate with barium. Have barium ion, sulfite ion, then you have barium ion, carbonate ion, barium ion plus carbonate ion to form barium carbonate, which is a white precipitate, then barium. This one we are going to we'll get to know more about this when you are handling practical part. Sulfite ion to get barium sulfite, which is a white precipitate. Barium sulfite, which is a white precipitate. Barium sulfite, which is so students, thank you for listening. Today I'm going to end from there, and as we shall be meeting, we shall discuss sulfur 6 acid, how it is prepared. That sulfur 6 acid, how it is prepared, large scale manufacture of sulfur 6 acid. Thank you for listening, and may you subscribe to our channel so that each and every time we shall be uploading a video, you can see how the video is. Yes, and you can comment anything that you wish in the comment section. Thank you.